Two numbers whose product is 36 and whose sum is negative 13. We always start with the product. The idea is the sum, the product of two numbers is positive. If the product is positive, these two numbers must be the same, must have the same sign. Do you all agree? Yeah. Because only two positives multiplied will give us positive 36, or two negatives multiplied will give us positive 36. Correct? Yes. Now this is the second step. We are looking at the sum. Since the sum is a negative number, they cannot be right. Excellent. So both numbers have to be negative, so that their sum is negative and their product is positive. Excellent. Can we come up with two numbers? Yes, please. So therefore, we know how to factor this. How do we factor it? I already have it. I don't need to split up anything. It's right there. I don't have to do that. I can do that. Oh, you mean to put x here and here? I don't need to do that. I already have the answer. Okay. But you can. Do not change anything that works. If I show you a different method and you like it, use it. If I show you a different method and you say, oh, I like mine, fine. So can anyone give us the factor form? That's it. In any order you want. It doesn't matter if you write it as x minus 9 times x minus 4 or x minus 4 times x minus... Oh, awesome. Great job. We accomplished a lot. Good. So now finally let's go to this, which is a different situation. The leading coefficient here is 1. We don't write it, but we know it's 1, correct? Right. But here it's not 1. This is specifically says not 1. So different method, different strategy, different steps. Good. So let me choose a problem. Here it is. Let's say 6x squared plus 11x minus 10. Okay. Here is how I start my thinking process. And the first step has to be this. What type of polynomial is it? It's a trinomial. Is it in descending order? Does it have a greatest common factor? No. I just want to give your new colleague this form so she can follow as well. And then I'll give her the rest afterwards. So this is the shortcut. This is the strategy. I gave you an extra thing. Okay, so here it is. Oops. So this is my thinking process always. What is it? It's a trinomial, so I will end up here. Not here and not here, but here. It's in descending order. Greatest common factor, you already said no. I'm going to ask now negative leading coefficient. Remember, these two steps can be considered one. Is there a negative leading coefficient? What if it were? I would pull out negative 1 first before I continue factoring, always. I will write it like this, and then factor the inside. The negative leading coefficient is in the way of our factoring. It becomes more difficult to work with it. Okay, ready? So now I'm here. I have to ask myself this question first. But in order for this to be a perfect square, this has to be a perfect square, and this has to be a perfect square, and this has to be positive, not negative. So a perfect square binomial is not the case. Or perfect square trinomial, actually. Okay. Is this the situation? Of course not, although I shouldn't even discuss this because the middle coefficient is not negative. So it's not this, it's not this. Is 1 the leading coefficient? No, it's not. So this is the very last option. If this method does not work, I will write that it's not factorable. To be exact, not factorable using integers. Okay? The book says prime. I don't really like that, but you can say prime. It's fine. Okay. So here's the method I recommend. If from your past math experience you know a different method, forget about mine. Why am I using this particular method? Is because it's the same method used here. And now, no, I'm not lazy. I can show two different methods, but there is no need. If I show this method here, I already covered this. So as we say, I accomplished two goals in one step. So that's why I'm using this particular method that I'm going to show now. So in the past, right here, 5 minutes ago, I should say, we said 36 was the product and negative 13 was the sum. Here you would say the product is negative 10. I covered the leading coefficient. The product is negative 10, and you will say the sum is 11, correct? But because the leading coefficient is not 1, I have to incorporate it in the product. Just the product changes, nothing else. So the product is negative 60. The sum stays the same. Can anyone tell us the sum? Yes, that does not change. However, the next step will be different. So first of all, we incorporated the leading coefficient because it wasn't 1. Did I do it in the previous problem? Yes, of course, but I didn't tell you. I still said 1 times 36 is 36, but I didn't say that, right? So at this point, I'll have to find, again, we start with the product. This is the key. The product gives us the sign of the numbers, so you do not make a mistake. Since the product is negative, it is a must, then one number must be, and the other one must be, exactly. There is no question there. We only have one option when the product is negative. When the product is negative, one number has to be positive and one number has to be negative. Okay. Now, here's the difference. For a second, I digress. Here's the difference between me coming in to teach and you seeing the material ahead of time. Everyone is paying attention because you know what's happening. Normally, after 20 minutes of presenting, some of my students were asleep, sort of. But now you're paying attention. We have a conversation, and I see everyone is looking at me and everyone is participating. So that's why I'm tempted to continue like this, unless you say, no, it's not working. And then I have to change. I have to be very sensitive to your needs, and I am, and I'll make any change you want. Okay, so now, sorry for the digression. So I need a positive number and a negative number whose product is negative 60, and at the same time whose sum is 11. Now, you could say, well, this negative 60 is quite big. I agree. But when you look at 60, or when I look at 60, this is what I see. I see a 6 and a 10, prime numbers. I see 2 and a 3, prime numbers, and I see 2 and a 5. So that 60 is 2, 2, 3, 5. You can say, wait a minute, this is not an elegant way of writing it. I agree. I should have written 2 squared times 3 times 5, but that's not what my point here. My point is, can I use all these factors and come up with two numbers? One, a positive number, and the other one, a negative number whose sum is 11? One other indication I want to give you before you give me the numbers. Since the sum is positive, which of these two numbers is stronger? We say in absolute value, but for now I'm going to just say stronger, more powerful. The positive one, not the negative, right? Because the sum is positive. So the positive one will overtake the negative so that the sum is positive, right? So this number has to be stronger in absolute value than the next one. Otherwise, it would have been the other way around. If this were negative, then this one would have overtaken, would have the other one, right? Would have had more power. So let's group these. How do we group them? Exactly. But only one has to be positive. Which one? Specifically, the stronger one has to be positive. Yes. So it's 15 and 4. And how I did that? By simply looking at this prime factorization. I said, okay, 15 and 4. That must be it. Again, you can choose other methods. The next step is not this, because the leading coefficient is not 1. The next step is this. I'm using these numbers that you just gave me. So first of all, let me ask you questions. If you have any questions right now, before we continue. Well, this is the first example. We're going to have a few more. Is this okay so far? Okay. So in the next step, what we do is I rewrite the problem. And I'm using these numbers. Can anyone tell us how to rewrite the problem? Yes, please.
It's going to be 6x squared plus 15x minus 4x minus 5.
So thank you so much. So this term changed using these that we just determined. You can find other numbers that work. Only 15 and 4 will work. You can say, what about 14 and 3? It's not going to work, because 14 times 3 is not 60. Okay, and now the next step is something extremely important, which is this. What is it? By grouping. So here is the method that I always show, and I'm sure if you watched, you saw me do this. It may not be the same whiteout, but it's one of the ones that I finish up in a semester. So from these two terms, what will you factor out? And I'll tell you why I do this. 3x. What is left in parentheses? Excellent. If you do not get 2x plus 5 from the other two, something is wrong. You must copy it first. You can say, oh, I don't have to copy it first. I will not forget that this is what yes. But you may forget, you may put a different sign in here instead of positive, you may put negative, and then the whole thing collapses. So I recommend, I use the same procedure. It's up to you. You can use the method you like, of course, but I copy this first before I look at the other two. And when I look at the other two, I see a negative 2. Why? Negative 2 times 2x and negative 2 times 5. Now this piece becomes the common factor. These are two terms. This is term 1, or first term, and this is second term. And each of the terms have two factors. I should say 3 if you want 3 and x. But this factor and this factor, this factor and this factor. So they do have a common factor that gets pulled out, which is 2x plus 5. And this is the 3x. This is the negative 2. And you can say, wait a minute, prove it. No problem. It takes me 5 seconds to prove this. 2x times 3x is 6x squared. Minus 4x plus 15x is plus 11x. 5 times negative 2 is negative 10. Do we feel a little bit better about this procedure now? Are we ready for another one on our own? Yes? Okay, so let's say 4x squared minus 13x plus 3. Please do not forget to go through the strategy. Once you get used to the strategy, you will never make a mistake. You always have to start by saying, what is it? Then you have to say it's a trinomial. Is it in descending order? Greatest common factor, negative leading coefficient, and so on and so forth. And you will not have any difficulties. Please raise your hand. I'm coming over to help you if you need any help, if you have any questions, if you worked on something that you want to show me. Kayla, please. Yes. Right. If I put minus here, this will take over the positive 4, and this answer will be negative. So that's what 15, and this is 2. Exactly. Okay. if I choose the wrong sign, this will become -11, and this is not what I have. Right. Better? Yeah, excellent. Other questions, please? Yes.
How did
About a horizontal. Yes. Yes. Okay, so from the first two terms, I see an x in common, and 6 and 15 have 3 in common.
Oh,
So, yes, so we're factoring out 3x, and then 3x times 2x is this, and 3x times 5 is this. And then I copy it here in order not to make a mistake, and only now I look. -2 times this, -2 times that. Great job. Anyone else? So this is not friendly. It's not a friendly situation. These trinomials with a leading coefficient other than 1 that do not factor using a special product are not friendly. Excellent. Perfect. Yes. So now we look at this product. Since the product is positive, then we have two options, both positive or both negative. But now I'm looking at the sum. I cannot add two positive numbers and get a negative number. So that's not the case. So obviously both of them have to be negative. Okay? So that their product is 12. And the sum is -13. So I can only have 1 and 12. Because 1 times 12 would be -1 times -12 would be positive 12. And when I add these two numbers, I do get -13. Both conditions have to be fulfilled. So now I will write equal symbol. I will copy the first and the second term, and then I will copy these two instead of -13x. I will copy -x and -12x. And then factor by group. Is that better? Anyone else? How are we doing with this problem? So we want the product to be 12, so let's write this put here. I don't know how you want to write it or not. You don't have to use. Okay, then the product is 12 indeed, and the sum is -13. Perfect, and let's put the sum. So I always start with the product because the product, if the product is positive, both numbers have to be either both positive or both negative. But since the sum is negative, this will not work. Both negative, so that I can, when I add them, when I add the two negative numbers, I get -13. So I can only have -1 and 12. Because the product would be indeed positive 12, and the sum would be indeed -13. Both conditions have to be fulfilled. So once I have that, then this middle term changes into -x minus 12x, which is still -13. So we write equal symbol again. We copy the first term, and we copy -x minus 12x, and then plus 3. Perfect. So now from these two, we will factor something out. We cover these two. So what do we factor out from the first two? Yes, of course. So let's put x outside and in parentheses. And we have what in parentheses? Yes? 4x minus minus 1. Exactly. Close the parenthesis. And now put here the same quantity. Has to be. I cannot go. I have to write words -1. And now let's see what we can pull out. We need a symbol and a factor. So we have to pull out something from these two, so we get the same thing in parentheses. Yes. Yes.
No, I do it this way. So when did you not factor it?
I factored it because it was a big number. It was 16.
Okay.
Otherwise, for these numbers, there is no need. How are we doing? Okay. A negative. A -3, so it works. And then we pull out the common factor. Yes. Yes, we have to copy it again. Before no, we have to copy it. If we don't copy it, we may come up with something. And now you have to find the sign and the number in front. Okay, got it? And then we factor out for x minus 1. Excellent. Okay, I'm happy. I'm happy with what I see. So I'm happy that you're helping one another. I'm super happy if you form study groups. I'm very happy. Okay, you want me to turn it down a little bit? I don't know. It was like that when we came. Okay. So I want you to form study groups. I want you to work together in class on problems. It will be fantastic. Okay, so from what I've seen, everything is fine. I'm happy. So we realize that it's a trinomial. It's in descending order already. No greatest common factor, no negative leading coefficient. This doesn't work because these are not perfect. This is a perfect square, but this is not. This doesn't work because the leading coefficient is not 1. This is the final chance. Nothing else is possible here. So then we said we are looking for two numbers whose product is 12 and whose sum, is negative 13. I always look at the product first. The product tells me that there are two possibilities, two positives or two negatives. Multiplying two positive, multiplying two negatives, I'll get positive 12. But since the sum now, only now I look at the sum and I'll say, no way, this cannot work. Plus, plus, plus will not be negative 13. So obviously both numbers have to be negative. We found negative 1 and negative 12 as fulfilling both conditions. The product is this, the sum is this. Since this is not 1, I cannot write this. This will be wrong. Please do not write that. You can write this only when the leading coefficient is 1. Yes, please. Go ahead.
Combine two common factors to multiply those two numbers. Doesn't matter which way you put it.
No, you will get the same answer. You may get it switched, but you will get the same answer. So you either write negative, it's a perfect question. You either write negative 12x minus 1x, or you write negative 1x minus 12x. You will get the same answer. When you multiply them, you'll still get the same original problem when you multiply them out. So this is the only time in which you can go ahead and write this. This is not that case. You cannot do this. Okay? So there is an extra step here. What is the extra step? The extra step is that from here, I replace this middle term using these numbers. So this is 4x squared minus x minus 12x and plus 3. Since everyone did this, do you want me to show the other one with negative 12x and minus x? Perfect. So it's the same thing with 4x squared minus 12x minus x plus 3. You can write it like this or like this. Same thing. So I am not kidding when I show you this. It's the best thing to do, I think. So we factor out 4x in this case, and we get x minus 3. If I do not copy x minus 3 first to see it, to have it under my notes, I may write something else or I may not know how to continue. So this really helps me see that over there. And now, only now, I look. Okay, no problem. So it's negative 1. Because negative 1 times x will be negative x, and negative 1 times negative 3 will be positive 3. Do we agree so far? Yes? What would you pull out? Well, this is term 1. This is second term. And they both have a common factor. Do not erase it like that. Don't cross it out. There is no need. I'm just pointing out that you factor out x minus 3. And what you have left is this, which is 4x minus 1. Or if you write it as 4x minus 1 times x minus 3 is still the same thing. Very good question. Anything you have for me on this one? Can we move on from this particular type of problem? 2 problems are not enough for us to remember this. So you should practice with 4 more problems as soon as possible. Is this okay? Okay, so let's continue. Let's go back to what we had. So, now, any questions on these difference in sums of cubes? Did we have any questions on the difference in the sum of cubes? Okay. Do not be shy. This is we are a work in progress here. So we ask questions of each other, we ask questions and solve the problems. Okay. So this was the second one. So these were situations in which, if you paid attention to this video, in which the first coefficient, so this is in trinomial, descending order, no greatest common factor, no negative leading coefficient, special product. I always hope for a special product. With a special product, I'm done in 3 seconds. With everything else, it takes a long time, or longer time. So the first term is a perfect square, this last term is a perfect square. I hope for this. But, careful, we still have to check the middle term. How do we expand this? We studied last time how to expand x plus 5 squared. It has how many terms?
2, 3.
Yes, a binomial squared, right? That's how we started last time. A binomial squared has 3 terms, right? So, otherwise, how can they be equal? Right? Binomial squared has 3 terms. So what is the middle term here? 2 times 5 times x. So the key here is not just to look at the first term and the last term, but also check the middle term. If you don't check the middle term, it's not guaranteed, right? So here's an example for you. So when I use special products, if they're applicable, right? So if I have, let's say, x squared minus x plus 4, you would say that's no problem. It's x minus 2, everything squared, right? X squared is the first term, and negative 4 squared is the last term. Not so fast, you should say. Hold on. What is the middle term here? Yes, it's negative 4x. Middle term, as we studied last time, first term squared minus 2 times the first times the second plus the second term squared. The middle term here is negative 4x, but look at the middle term here. Can this quantity equal this quantity then? No, they're not the same. So don't jump into conclusions. So if you have, let's say, x squared plus 6x plus 9, what will be your conclusion? Excellent. What is the middle term? Can anyone give us the middle term here as we studied it last time? Say it again. 6x. If this term is 6x, then this piece equals this piece. If this term here that I covered is not 6x, the left-hand side does not equal the right-hand side. Is it 6x? Does it make sense? Should I give another example, or is it clear? Clear. Okay, let me know. I can always go back. Okay, so this is what this means. This is what I was saying here. This, if I don't look at the middle term, I will say, oh, it's x plus 5 squared. No, it's not. What is the middle term of this expansion? When you expand this into how many terms again? 3 terms. What will be the middle term?
10x.
Right, but do we have 10x here? No, so they cannot equal each other. Okay, so these were other examples from that handout. This was a typical example on the factoring by grouping, exactly what we just looked at a few minutes ago. And then we continue to linear and rational inequalities. So any questions on linear and rational inequalities? I'm going to practice now linear and rational inequalities right this moment. Yes, please.
Yeah, rational. Anything with
Yes.
action is a denominator.
Excellent. Yes. So that's what we're going to do at this point. We're going to pick any rational equations and look at, but I will start with a linear just for refreshing your memory. And then we'll look at more quadratic equations. Excellent. Good. Okay. I'm creating a folder, a file in which I save all the video links for the class. So then if anyone asks later, then I can send them the file with everything. Okay. So are we okay with linear equations? If you say no, I'll show an example. If not, I'll go directly to rational. Yes, yes. Okay. Linear. I'm picking from your book. Okay, here it is. On page 120, let's say problem 13. 120, so this is 16 equals 3, x minus 1 minus x minus 7. This is a linear equation because it doesn't have the square root on the variable. It does not have 1 over x, and it does not have a product like x times y. None of this is here. And also the powers of the variable are always 1. So this is linear. A linear equation. Okay. How do I solve such a linear equation, or linear equations? Yes, first I have to eliminate, that's my first step. Eliminate parentheses. So this is 16 equals, we distribute 3 to 2 terms and negative 1 to 2 terms. So then we have 3x minus 3 and minus x plus 7. So let's think for a moment and you tell me if this is clear. Clear. The next step I recommend, they're all recommendations, right? You know that. You choose the method you like. I would immediately combine like terms. 3x minus x is 2x. 7 minus 3 is positive 4. I personally prefer to keep the variable on the left. But I'm not going to go to super extent to make that happen if it works, and I only need one step to move forward to the other side. Yes, I know you want to write minus 4 to both sides. Please continue doing that if that's what you want. I will not. When I move a term from one side to the other, it's positive 4. I move it to the other side, it becomes negative. 16 minus 4 is 12. So 12 equals 2x, or 2x equals 12. You can read the equation from the right if you want to. As the final step, what do we need to do to get x? That's it. And it's done. That's the linear. Again, you will not remember if you don't practice. So they are on page 120. If you come across something that you have difficulties with, always bring it to class, from homework, from book, from previous lectures, from our lecture, from anything, from anywhere, please. Okay, so now when we talk about rational, that's a different story, totally different story. So I'm going to pick an example. And I'll explain what they are. Let's say 43. In 43, I have 3, on page 120. 3 divided by 2x minus 2 plus 1/2 equals 2 over x minus 1. Why is this a rational equation, first of all? Yes, please.
There's x in the denominator.
Exactly, that's the answer, correct answer. If there is no x in the denominator, that equation cannot be rational. Something like this is not a rational inequality. Equation. So 1/2 x plus 1/3 equals x. This is not a rational equation. It does not have x in the denominator. This is linear. Okay, so I look at this denominator and I realize that I can't factor anything. This is already factored. I cannot do anything to 2, but I look at 2x minus 2 and I realize that I can factor. That's why we reviewed factoring before these equations. Here I have no choice. What will you factor? Yes. And what will you write in parentheses? Excellent. Very good. So that's my first step. I will make sure that all denominators are factored. My second step, I will state restrictions on the variable. Our variable is,
X.
that's what we are solving for, and this is our variable. How come? How come I didn't state restrictions here?
Because you can't be a 0.
Here there were no restrictions. But here, why would I even think of restrictions is because the denominator of a fraction can or cannot be 0. Cannot. So in a over b, is this a fraction? The denominator cannot be 0. This is mandatory. Why? Division by 0. We like to use this fancy word, undefined. What does undefined mean? It doesn't exist. I can't replace it with a number. That's all it means. Division by 0 is undefined. Awesome. So then, what do we see? X minus 1 cannot be 0. I'm not going to write that 2 cannot be 0. Of course 2 cannot be 0. And then x minus 1 again cannot be 0. Well, there is only one condition then. It means that x cannot be 1. So once I solve this equation and I get, let's say, x equals 1, what will I say? The equation has no solutions. The equation has no solutions. Do we all understand the restriction? Do we understand why x cannot be 1? Yes, Kayla, please.
So no solutions and undefined is 2 separate things.
Very good. Excellent. When I say no solutions, I'm talking about an equation or an inequality. When I say undefined, I'm talking about a fraction. Okay. No one has ever pointed that out to me. Thank you. So when we talk about undefined, we say a function is undefined at a point, or we say a fraction is undefined at a number. But when we talk about no solutions, we are trying to solve something that has no solutions, that has nothing to do with undefined. It may be the undefined situation, but there are two different things. Thank you. Good. So at this point, I recommend moving everything to one side. So I have this. I'm just copying. You don't have to copy. I just wrote a lot of stuff in between. So I copied the step that I was at with x not equal 1. So I will move everything to one side and set it equal to 0. If I omit to write 0 on the other side, I'm changing the equation into an expression. And I will never solve. I will never find x. So can anyone explain why is 0 on this side? Yes, I'm moving. Yes, but I'm moving this term to the other side. Something has to be there. Every equation has 3 portions, 3 pieces. The left-hand side, the equal symbol, and the right-hand side. If you drop the right-hand side, you're changing the equation into an expression, and you're not going to solve rings. Does it make sense? All equations, if you need to write that down, please do. All equations have 3 pieces. The left-hand side, the equal symbol, and the right-hand side. So that's why I have the left-hand side, the equal symbol, the right-hand side. The left-hand side, the equal symbol, and the right-hand side. I'm asked to solve. If I drop this, I'll continue simplifying, but I'll never solve. All equations are on one row. You cannot continue with the equal symbol to the left or to the right. So please do not write to the sides anything. Left-hand side, equal symbol, right-hand side. Left-hand side, equal symbol, right-hand side. Clear? Okay, perfect. Now I have to find what it's called least common denominator. Please write the fraction line and equal symbol and 0. Again, if you know a different method, forget about mine. I'm fine. Promise, I will not take it personally. Okay, so how many different factors we see here? Different factors. How many?
2.
Yes, I see 2 and I see x minus 1. There is nothing else. All different factors must be in the LCD. Mandatory. If you have 10 different factors, then 10 different factors have to be there. If you have 2, then 2. Okay, now this denominator happens to be identical with this, which means the numerator will not be adjusted in any way. By no adjustment, you can write 1 on or nothing, bless you, or nothing. 2 was multiplied by what to get this? Which means that I have to perform the same operation. That is not a fraction line. This is only a reminder saying you multiply the denominator by x minus 1, you have to multiply the numerator by x minus 1. Now, x minus 1 was multiplied by? It means that the numerator has to be multiplied by the same quantity. Can anyone courageous enough, I'm kidding, will give us the numerator? You don't need courage for that.
Might be 3 plus x minus.
Yes, positive 1 times x, positive 1 times negative 1. Negative 2 times 2. That's it. At this point, we have two options. Option number 1, it's up to you. If you have a third option, use the third option. I'm fine. Option number 1 is to say that a over b is 0. A over b is 0 only if a is 0. A fraction is 0 only if the numerator is 0. And I'm done. Option number 2 is to write this over 1 and cross multiply. Because now this is a proportion. Both methods are extremely important. A divided by b equals c over d. This is a proportion. Only in a proportion, again, I caution you, proportion means one fraction on the left, the equal symbol in the middle, and one fraction on the right. If you put plus 1 here, that's no longer a proportion and you cannot do this. So a proportion means two fractions that are equal to each other. And I can write a times d equals b times c. Which method would you like to choose? You don't have to stick with one. You can go back and forth.
Proportion.
I'm sorry?
Proportion.
You want to use proportion. Very good. So then we say all this times 1 is itself x. So this is negative 5 plus 2. So x minus 2 equals 0. So let's do this one more time. So x negative 5 plus 3. So all this reduces to x minus 2. X minus 2 times 1. X minus 2 times 1 is x minus 2. And all this times 0 equals 0.
Can you do that again?
Yes. Is it clear that the top reduces to x minus 2?
Yes.
So I have x minus 2 over 2 times x minus 1 equals 0 over 1.
Wait, how do we get x minus 2?
X negative 1 minus 4 is negative 5 plus 3 is negative 2. All this piece reduces to x minus 2.
Okay.
Is that better? Yes? We see that? So now I'm using the proportion. We suggested to use the proportion. So x minus 2 from the top multiplied with the opposite denominator, I get x minus 2. The bottom of the first fraction, 2 times x minus 1 multiplied by the opposite numerator gives us 0. This product is x minus 2. This product is 0. Therefore, x equals 2. My first thought first thought immediately is this. Is x equals 2 on the list of restrictions that x cannot be? No. So then I'll say, unless I made terrible mistakes somewhere, that's not going to work. But most probably, 99.99%, I did not make a mistake. I still have to say, well, it's potential, it's possible. But I don't think we made any errors. So x equals 2 will be the correct solution. Can I go back and check? Yes. Is it mandatory to check? No. Now, the other option was the first one, meaning I have x minus 2 over all this equals 0. A fraction is 0 only when the numerator is 0, and we get the same answer. It's up to you. Please.
If you had a trinomial in the denominator, would you just?
I have to factor it from the very beginning. You can simplify if you want to. That's fine, but you have to state restrictions first. Be careful. Yes, you can. I accept any method. Absolutely. The reason why I don't use that method is because students will be tempted, not everyone, but students will be tempted, and here's why. So for example, I have something like this. Students will do this. Not everyone. Is this correct? No, it's not, because this is a product of two factors. But this whole thing is a term plus another term. You're not allowed to simplify a piece of a term with a factor. So that will not be allowed. This is why I never even write that. But if you know what you're doing and you would distribute and you combine like terms and then factor and simplify, it's perfect. No problem there. How are we doing with rational equations? Should we work on another, on our own?
Yes.
Okay, ready. So let's look at 49. I'm copying 49. And this is still on page 120. 1 over x minus 4 minus 5 over x plus 2 equals 6 over x squared minus 2x minus 8. There are a lot of steps.